Hi everyone, welcome back to part 2. We're going to make tile collision. Now, like I mentioned, this is mostly compatible with Shaun Spalding's action RPG series. So if you followed along with his INI and set up the tile collision, you probably noticed one thing is your speed value had to be an integer, and when he moved into collision tiles, it checked against his origin on the bottom center, so half of his sprite would still go through a wall. And it's good for beginners, but we're going to show a more robust tile collision method in this episode that will use bitwise operators. So for right now, we're just going to create a sprite called sCollision. It'll be 32 by 32, and we're going to turn this into a tile set. So remember, when making tile sets, the top left is always your blank space. So we'll put a transparent red square in the next space to the right. Just like that. Make sure it's 16 by 16. That's the tile size we're going to be using. And we can remember that in our constants. We can set up a constant for tile size, as I've already done. Now create the tile set, and then we'll add the sprite to it. Call it tCollision. Alright, that's already set for us. Now we're going to go into our room, our parent room, and we're going to add a new layer, a tile layer, just called collision. I like to keep my instances at the top since that's where we'll be adding the most resources. Now in test room, see about inheriting that. There we go. Okay, because it's a child of the parent room, so we can inherit that layer. Set it to our tile collision, and so we can begin to paint on where we want collision to be with the red squares. So I'm gonna border the room, and I'll do that real quick. Okay, something like that. It doesn't really matter, just as long as we have something to test against. And now we want the player object to hold a reference to that collision map, to that tile layer. So, back in our player object, let's create a new variable called collision map. It's layer tile map get ID, and then we want to get the ID of the layer. And then we can just type in what we named that layer. Okay, so in a new tab, let's create a new script called player functions. In this script, I'm going to create any functions that can be reused across multiple states. So for our first function, let's just call it collision handle. Now, one thing we want to do inside player states is to remove where we set the coordinates to change with H speed and V speed. We need those to go in between the tile collision. So the commitment to our movement will be called in the collision handle script, so we can go ahead and call that at the end of this. Now back in collision handle, we'll structure it like this. So first will be the commitment to our movement. Followed by the tile collision. Then we'll do the same for the Y. Okay, so let's actually begin working on our tile collision. So first we're going to create two local variables, called pixel 1 and pixel 2. And the first collision we're going to check is when we're moving right and we hit the left side of a wall. So the player's right side is hitting the wall's left side. So let's check if h-speed is going above 0. Positive h-speed values are moving right. And now we're going to set our pixel 1 and pixel 2 to something. So imagine this is our player. If we're moving right, we want to check for what's hitting this corner and this corner. We're going to check for what pixel is at this corner and what tile it's a part of. So to get the pixel here, I'm going to say, if I remember right, tile map get at pixel. Yeah, tile map get at pixel, that variable we made, collision map, that holds the reference to the tile layer. And now for pixel 1, it's this. Pixel 2 is going to be that. So to get the X and Y we're looking for, we want the right boundary box of the player. So, not the origin. Remember, origin's bottom center. We don't want that. We want where the whole right side of the collision mask is hitting. So to get that, we call bbox right. And if we're looking for this corner, the other one we want is bbox top. And then pixel 2 is going to get this one. So exact same code, just replace top with bottom. Okay, so what this is returning, what these tile map get at pixels are returning, is they call it like a data blob, but it's essentially a bit mask. Let's look in the manual real quick. Okay, so they say right here, to get the tile data from the function, it will return the tile data blob. This blob is essentially a bit mask that contains the tile index. Okay, so what do we mean by bit mask? So if you go to a page in the manual called bitwise operators, there's a whole page in here about bitwise machine language based around zeros and ones. I highly recommend reading through this whole page if you get the chance. I can't explain everything about it right now just for tile collision, but we're going to use a few functions in here. So when we're getting a mask, when it's getting that data blob, what it's returning is a long string of zeros and ones. And now there's another constant in GameMaker called tile index mask. And this also is a data blob, and what it says is it's a special constant that is for ANDing with the tile data blob to extract the tile index. So what it's saying is that if we use this constant, this built-in constant tile index mask, and AND it with the results of tile map get at pixel, it'll return the tile index. It should return the specific square in our tile set. So if it's the top left blank space, it's 0. If it's the red colored in space, it's 1. So what does it mean by ANDing? Now, normally you would use two ampersands, and a conditional like an if statement to check if two statements were true. Like the bitwise and, that's not what they mean. Let's go back to the bitwise page in the manual. For the bitwise and, you only use one ampersand. Alright, here's an example. This is a truth table they have set up. So what's happening with the bitwise and is that it checks for a bit, a 1, in the same space as the first value. It combines them, and if there's the 1 in both spaces, then it returns true. Otherwise, it'll be false, as you can see with the first three examples. There's a longer example down here using keys and doors. I recommend reading through this on your own time if you get the chance. End of the day, what that is doing, what's happening when we AND these values, is we're just going to find which specific tile in our tile set it's looking at. If it's 0, it's the top left. If it's 1, it'll be this red one. And remember, when we're using the bitwise AND, it's only 1 ampersand. You're not checking if both these things are true. You're seeing if you're seeing which bits are contained in this, and if they're also contained in that. I think that's the best way to put it. So we want to make sure that both pixels are hitting the blank space, that they're not hitting any other one, any other collision we might have. So we want to say, oops. So this will be the collision. So if pixel does not equal 0, or pixel 2 does not equal 0, so as long as one of these are hitting a red space, a collision space, anything that's not the top left, then we want to stop the player and move them outside of the wall. So now we have to figure it out exactly where do we place the player? How far out of the wall do we place them? Back in the bitwise manual, there's actually a section here for tile alignment, and it pretty much tells us exactly what we're looking for. Right here they have an example. If you're moving to the right and the right side of your player hits the left side of a wall, what can you do to move it out of the wall? What you type in? This. They tell you exactly what we're looking for right here. So what's this then? What's this tilde 31? So the 31 is your pixel size minus 1. In this example, they're using a 32 pixel size. In our project, unless you deviated from what I'm doing, we're using 16. So this would be 15 in our project. And they say if we're moving out of the space, if we want to move a pixel boundary to the left, moving out of the collision, we're going to use the inverse of the bits. So this tilde here is the bitwise version of not. It's not the exclamation mark we usually use. That just means that a conditional isn't true. Rather, the bitwise not is about inversing the 0s and 1s. You flip them around. Let me see. Yep. Okay, here's the table for that. As you can see, knotting 0, 0 becomes 1, 1. That seems all self-explanatory. That's not too important to understand for this. I don't believe I use knots anywhere else, bitwise knots. So very simply, we can type that in here. X equals X and bitwise and, not our tile size minus 1. Of course, we don't really want magic numbers, so you might remember at the beginning of this, I showed I had already created a macro for our tile size, 16. So we can do not tile size minus 1. Put these in parentheses so that it's you can make sure it's subtracting before we not it. Now, one issue you may notice here is when we're moving our X like this, our X is at the origin. So if we're moving out of the wall, we've really only moved halfway out. Half of our character would still be in the wall. So rather than using X, how about we use our boundary box, that B box right. Now in addition to that, to actually fully move the player out of the way, we need to get the size of this other half. What's the size of the space from the origin to the end of the boundary box? And we'd like to get that on each direction. Well, the bottom will just be 0, but just in case you have a sprite where you don't have the origin exactly at the bottom, we'll go ahead and add one for that. So back in our player object, let's create some new variables. I'm going to call this right, well, I'm going to call it bbox right portion. And so we're going to get just half of the player size. What is the boundary box to the origin? So to get that, we use sprite get bbox right, then enter a sprite index, minus sprite get x offsets, that checks from the origin of our sprite index. Okay, so let's do one of those for each of the 4 directions. Just remember, for top and bottom, replace x with y. So let's do that. Okay, so after this whole thing gets ANDed together, we can subtract the right portion, and that should completely push the player outside of the wall. Now, I still get some issues when doing this, so I find you actually need to subtract another 1 pixel here. I know that might seem a little confusing, and make sure these are all in this right order by using parentheses. Okay. I mean, there's still a lot I have to learn about all the bitwise stuff and everything, but I find you need to subtract just 1 more pixel from this to get it to really work correctly. Alright, so once we do that, we can do the same for the left side. So let's go ahead and get the pixel 1 and pixel 2 we need for that. So we're good there. So now where do we put our X if we're moving to the left and the left side of our player hits the right side of a wall, the opposite of this? So they actually tell us that in the manual as well. So back in that tile alignment section, they say, well, what if we wanted to align to the right of the wall? Then we do the above, but then add 32 to move it into the next tile. Simple. Alright? So with that in mind, we can use pretty much the same thing. So we would use bbox left plus tile size. Let's keep that together. And then we can AND it by the not tile size minus 1. And now for this, you don't need that additional 1 pixel. It should work fine without it. Or I guess you would do plus on this side anyways, but you shouldn't need it at all. So let's make sure all that's together, and then we can subtract the left portion of our sprite. Okay, so I hope that makes sense. Like I said, it's not super important you understand exactly how this stuff works, as long as it works. But we're going to use the same thing for the vertical collision. So off screen I'm gonna retype all of this just for up and down. So remember to keep your rights, lefts, tops, and bottoms in the correct spaces and change the X's to Y. And let's do this real quick. Alright, there's our vertical collision. So because 0, 0 is in the top left, the bottom is the equivalent of right. So when v speed is greater than 0, we'll do the bottom one. The alignment matches what we did for right, and same with left and top. So make sure you've put everything in the right space, that your parentheses are correct, and that your code matches what you see on screen right now. Feel free to pause if need be. And with that done, let's see if it works. Alright, there we go. Everything seems to be working just fine. If you're encountering any issues, remember you are to add the collision handle into this player state, the player move state, and also make sure that the commitment, where we actually set the coordinates to h speed and v speed, are before the collision for that axis. So commitment first, then tile collision. And if issues still persist, make sure everything matches what you see on screen here. Okay. So not everything we want to collide with will be a tile. Traditionally, if you are starting off on Game Maker, you probably used object collision. You probably made like O solid or O wall, and then spread those all over the room. Tile collision is more memory efficient, vastly so, which is why we use it. However, there's still times where you might want an object that you can collide with that won't align to the grid. So what if we had an object that has its origin at the bottom center? You know, you can't paint the grid collision over that, or maybe even an object you can move, like if you threw it like a rock or something, then, you know, obviously it can't be tied to where you painted a collision tile in the room. So let's create a new sprite, and let's just make like a something you would collide with, like a treasure chest. I'll call it S chest. I'll make it 16 by 16, and I'll just try to paint a chest here. I'm not an artist, so give me a sec. There, something like that should work, look nice. Okay, so like I said, we'll make the origin the bottom center. Now naturally, well, I guess I don't have an object for it. Okay, so let's make it an object, and right here I'm going to use as an opportunity to introduce a new element. So I'm going to create a folder called entities. Okay, so now after our whole collision thing, we're going to go back to being compatible to what Shaun Spalding was doing. So in his series, he created a parent entity where he could define a number of variables from, and then it could have a large number of children, which would be various things in the environment, chests, NPCs, and so forth. So I'm going to do the same thing because it works, and like I said, I would like to keep these series somewhat compatible, at least for the exploration of the world area. I mean, obviously for the battles we'll do something completely different. So call this P entity. Now, if you've already watched some of Shaun's videos or followed along with his, you know, he defined a number of things in the variable definitions, like activation scripts and arguments for the activation scripts. Right now, I'm just going to call one is solid, and this will just be a Boolean that checks to see if this object is one that should be collided with or not. We'll add more to these entities as we go along, but if you've seen Shaun Spalding's series, you already know how this is going to work, how we're going to set it up. So let's create a new object called OChest. We'll make its parent the entity. We'll give it the sprite. And in variable definitions, we want the isSolid to be true. Now, if you were to add it right now into the room, like I said, it's going to be origin center, so it's not going to be evenly aligned with the grid. So if we were to try to paint collision on top of it, you see it wouldn't evenly fit. We would have two collision tiles, and they would go over the sides a little bit. And especially for NPCs, we'll want the origin to be in the center for when they flip left and right. So let's go back into the collision function, and now we're going to add a new type of collision, and we want this one to be on top of the commitment to horizontal movement. So let's call this horizontal entity collision. And now remember, for these to work, you got to do them in the right order. Entity collision first, commitment to movement second, and then tile collision third, and then repeat for your vertical axis. Okay, so first we're going to create a local variable that will hold the ID of any entity object, any child of P entity that's in front of us. So we're going to do instance place xy P entity, and now to check that it's in front of us, you'd think we would do something like +1, but remember, our player doesn't always move at a speed of 1. So, as an example, there's our player again. Imagine the thing we're colliding with is here, and say there's 3 pixels in between. And our character moves, I know he doesn't, but let's just for example say we gave his move speed the value of 4. So if he moves 4, and if we have the instant place where it's x+1, he's only checking 1 ahead of him. So what we actually want to do is see if there's an instance placed within his move speed range, how fast he's going. Otherwise, he'll clip through the wall. So instead of that, we want h speed, how fast we're going on the horizontal axis. So if we're just moving right, then that would be, 1.5, I think is what we set our move speed. And if you're moving to the left, that'll be negative 1.5. And so, if there is an entity in that space, and the entity is solid, then we'll do our collision. And this is very classic object collision. You've probably seen this in plenty of other tutorials. The oldest platformer tutorials around have similar code. So first we check to see if the object was in front of us. So if we're moving 4, if the next space we'll go will be 4 pixels jump, but we detect that there's something 3 pixels ahead of us, if we just detected that now and said, stop, put your HP to 0, we'll end up 3 spaces with us between the wall. We won't actually go all the way to the wall. So once it checks that the next entity that we'll collide with is within the range of our move speed, we'll stop advancing the horizontal speed normally, and instead we're just going to increment the X value by 1 pixel at a time until we hit the wall. So to do that, we're going to use a while loop. Alright, so while not place meeting X plus the sign of our H speed. Remember, if we're moving left, it'll be negative values, so we can't just do +1. We need to make it so it can be +1 or -1, depending on the direction we're moving. And then Y, and then the local variable with the ID. So while we're not... So this will keep going through this loop until we're smack dab against the wall, and the next pixel after ours is the wall. And we want it to do this. Like I said, we'll just increment X by just 1 pixel at a time, and then in the direction we're going. So it'll be -1 pixel at a time if we're moving left into a wall. Alright, and when it's done with the wall loop, our H speed is set to 0. And that's really all you need for object collision. Like I said, that's old platformer tutorial stuff. You've probably seen it before if you've been going through other Game Maker tutorials. And then we want to do the same thing for vertical. Again, remember the ordering needs to be entity collision, commitment, and then tile collision. So I'm going to type up the same thing we just did for the vertical. That's finished. You can see, just replace H speed with V speed and make sure you're operating on the Y, the field that holds the Y value, not the X, and otherwise it's the exact same. Okay, so I believe we already added the treasure chest to our room, right? Yeah. So let's go back into that. After the most recent 2 updates, I noticed it's very slow to start. It gets going after a bit, though. In case you thought something was off about that. Alright, so we got tile collision working fine, and we can collide against other objects just fine. So that all works. So you might remember in episode 1, in our parent player, I added this end step event that adjusted the depth. So let's work with that a little bit. Let's add that same code to our entity. Okay. Now let's go into our sprites, like our player sprite, go into collision mask, change it from automatic to manual. And in case you didn't know, when I was talking about boundary boxes when we were doing all that tile collision, like this is what I mean by boundary box. Like, Game Maker's built-in stuff to detect where you actually want the sprite to collide with. It's automatically set to just cover your whole sprite, but then you can set it to manual if you want to adjust it. So when we do this, bbox top becomes this, and that bbox top portion variable we made becomes this space, just from the origin to the top of this collision mask. So let's set this down to only be halfway on the player, and let's do something similar to our chest. we'll pull it down a little so you can get behind the chest a couple pixels. Well, maybe a little lower than that. Okay, so both of those have that update depth I did, where their depth will equal the negative value of their B-box bottom. So where the bottom of our sprite is where it's getting the depth. So as you can see, I can now move in front of walls just fine. Those aren't on our layer, so that didn't really matter, but with another object on the instance layer, you can see I can now move in front of that. And similarly, when I get behind it, same thing, it gets in front of me because it's lower down on the screen. It has the greater depth value. So that works just fine. Before we leave, there are 3 things I want to point out about our tile collision, the way we have it set up. First of all, you always need to have at least one collision tile somewhere in your room. Otherwise, your character will go flying off screen. The second thing is, and this can be both a blessing or a curse depending on what you are trying to do, it makes it so the actual boundaries of the room box in your player. You can't leave outside the room because there's no tile map beyond the room. Alright, so you don't actually need tile collisions on the edges of your room. And the last thing is, back inside our scripts, it's actually arbitrary which tile from our collision tile map you have set to be the walkable space. What we have here is 0, which was that top left, but we could just as easily put 1 in here. And same with the vertical. And back in our room, put the player on top of a red space. Now the red space is the walkable space, and the blank space is the collision. So I don't know why you would want to do this, but if you did, you could paint in walkable space. However, I wanted to point this out because this will be important later when we make our overworld, and we have the player character who can walk on land but not water, and a boat that can move on water but not land. That's much later in the series, though. I just wanted to point it out while we're on the subject of tile collision. I'm going to change those back to what they were. And so, in the next episode, to begin, I want to already have room transitions set up. I'm going to make a test room B, and then I'm going to have a door object and a fade effect object, and the player will be able to move between test room A and test room B. So, Shaun Spalding, his action RPG series, already did a room transition episode. I'll have a link to it in the description. And for some homework, I'll have you go through, follow his, and see if you can set up the room transition on your own. If not, don't worry, we'll quickly go over it at the beginning of the next episode. But then we need to start moving on and talking about setting up our characters, party members, and stats. We'll be using constructors for that, so if you're not familiar with those that were added in the 2.3 update, make sure you look those up and get some understanding of them, and then I will see you in the next episode. Thanks, bye!